99% of Earth's surface history is hidden beneath ice. The Pleistocene epochs covered continents in colossal, slow-moving ice sheets. These frozen rivers moved with unimaginable abrasive power, reshaping everything. But we explore the 5 major ways these glaciers sculpted our modern world. First, the immense power of glacial scoring carved deep depressions. And as the glacier moved, rocks embedded within it acted like sandpaper. But this process leaves behind telltale scratch marks known as striations on exposed rock. When ice retreated, these scarred paths filled with meltwater, forming massive lakes. One can consider the Laurentide ice sheet, dwarfing modern ice formations. The sheer weight of that ice carved out basins exceeding 600 meters deep. And now that we understand scarring, let's explore the second major effect, deposition. But glaciers carry everything, sand, gravel, and massive stones, for hundreds of miles. When the ice melts, this unsorted debris forms glacial till, or drift. The leading edge of the glacier deposits massive ridges called terminal moraines. But these moraines act as dams, trapping meltwater and defining future lake boundaries. The third mechanism involves isolated blocks of ice melting underground, creating kettle lakes. But these small, water-filled pits are ubiquitous across formerly glaciated lowlands. Meltwater rivers flowing within the ice left behind winding, steep-sided ridges, eskers. And these features are crucial, as they often indicate ancient drainage paths and groundwater sources. And now that we understand continental lakes, let's explore fjords in coastal regions. The fjords are the marine result of glacial carving, fundamentally different from lakes. Rivers create V-shaped valleys. Glaciers transform them into deep, characteristic U-shapes. As the ice deepens the valley floor far below current sea level. But when the ice retreats, sea levels rise, flooding these massive troughs. Notice the shallow sill near the entrance, a terminal moraine submerged offshore. This sill restricts water circulation, creating unique, stratified marine ecosystems. But the fifth factor is glacial rebound, the slow bounce back of the crust. This isostatic adjustment continues even today, reshaping coastlines subtly. But ancient shorelines are lifted above current sea level, creating marine terraces. The sheer verticality of glacial erosion is what distinguishes these landscapes. The ancient Precambrian basement rock was exposed by the removal of soft overlying material. At the head of the valleys, bowl-shaped hollows called cirques formed. These cirques fed tributary glaciers, merging into the main valley conveyor belt. But drumlins are streamlined hills molded underneath the moving ice sheet. The blunt end faces the direction the glacier arrived from, the tail points away. Fourth, vast plains of sorted sediment, or outwash, stretched miles from the ice edge. Meltwater streams sorted the debris, carrying finer materials much farther away. These outwash deposits dramatically influence the development of major river systems. And this shaping occurred globally, from high northern latitudes to southern peaks. Tributary valleys, too high to be eroded as deeply, were left hanging. The combination of scouring and moraine damming defined the Great Lakes. The sheer weight of the ice compressed the crust, sinking the land marginally. This localized depression influenced later drainage patterns immensely. These erratic boulders offer direct, tangible proof of the ice's long-distance transport capabilities. Hanging valleys often become sites for spectacular, iconic waterfalls across the globe. The total erosive power exerted by the ice sheets is difficult to truly grasp. Mountains were sharpened, smoothed, and undercut simultaneously by these massive flows. Roches montañes, sheet rocks, show asymmetrical polishing from ice passing over them. These processes, repeated over millions of years, define the geography we inhabit. But even the outflow routes, like the St. Lawrence, were dictated by ice channels. The alternating advances and retreats created vast fluctuations in global sea levels. When ice was maximum, lower coastal areas we see now were dry land. These sediments contain the story of the glacial environment itself. The resulting terrain is often gently rolling, yet structurally complex beneath the surface. Every city built on this terrain is fundamentally utilizing glacial architecture. Whether inland lakes or coastal fjords, the principle of glacial deepening remains. Post-glacial erosion modifies these shapes, but the primary structure persists. The Ice Age was not just a period of coldness, it was Earth's greatest sculptor. Understanding ice mechanics is key to reading the planet's physical history. But these frozen giants left behind a world fundamentally molded by their passing.